Hey guys, what's up? Eddie Yahoo here with KissAnalog.com. Today I got a meter. Well, I actually got it yesterday. I got this meter, opened it up because I was wondering what the heck it is they sent me. Box is kind of messed up a little bit, and then I remembered. I went back and looked at an email, and they had sent me this because a customer had returned it and they asked me if I wanted it, and if I needed the parts, they would send them to me. But yeah, that was really nice of them. I've got this power supply and this guy here. Really like the LCR meter and this power supply up here. So this guy's pretty inexpensive. I'll have to look at the price, but yeah, link's gonna be down below, and I'll put the price right here. I want to say it's around $50-ish, and it's pretty small. Yeah. I had to open up the box to see what the heck was inside it, and then I looked up the price, and that was last night, but I want to say it was right around $50. So I was like, wow, pretty low cost. Hopefully it's gonna work well. Let's come over here and take a look. Thank you, Matrix, for sending it to me, and I appreciate it. Hopefully it works. So I guess we'll have to first get that out of the way, and then we'll see how well it works if it does. Somebody returned it, and the box is kind of messed up a little bit, and I don't see a manual inside, so yeah, who knows. Let's come over and take a look. Alright guys, so I did get this. It was a return, and Matrix told me they returned it, asked me if I wanted it, and I said sure. So they said, hey, if there's anything wrong, let them know, they'll send me parts, whatever. But it looks like I've got everything, I think. It's got these leads, which almost feel like silicone, but I don't think they are. They're probably just PVC, but they are pretty flexible. But see how it kind of holds bend? That tells me right away, even though they're soft and flexible, that tells me they're PVC. But yeah, they do have these nice solid barrels. They're kind of split, but they're pretty heavy. And then they've got the strain relief, nice strain relief on them, and the little shroud there, and decent sized alligator clamps. So, and they're about 1 meter long, I would say, maybe short of that. And then we have our power cord, and it says 3 times 18 gauge, so 105C, and so I think that, and it looks like it's UL approved, I think, or ETL US. So yeah, for this power supply, probably just great. And there's no manual, so I guess I wasn't returned with the manual. But oh well. There we go. Yeah, it's been, I mean, the display's got a little bit of abrasion on there, if you can see that. Now, it has 5 memories, so you can do a setup, like let's say 12.6 volts at 1 amp. Maybe you want to set that up, so you can set that up and save it. Over voltage protection, over current protection, and here's your voltage and current. I guess swap between them. And you're on off, so that's nice. You got your power button, and then this must be turning the power on and off here, so that's nice that you can do it that way. So pretty nice for such a low-cost power supply. It's the MPS-3206, 32 volts, 6 amps. Links down below. Appreciate using that. It doesn't cost you anything extra, and it helps support the channel. Looks like all the screws are in. Alright, now this is on 220, so this was returned to Amazon and then sent to me. So if that was sent somewhere in the US, that maybe might have been a problem. So we'll switch that over and see what happens. You know, guys, before we do that, I think we'll check out the fuse just while we're here. These kind of fuse devices have one that's plugged in and one spare one, so And I can already tell that there's a little smoke action here. Let me see if I can get this white background. Alright, if I can hold it still, you can see that little burn mark right where the fuse went. So that was pretty obvious. So let's go ahead and see if the other, maybe they went through both fuses. So you just use one fuse, push the other fuse out. And that fuse looks good. Yeah, that fuse looks good. So we might be in business, guys. Maybe it was that 220 thing. Or maybe they just started switching things around after it had a problem. So we'll see if this thing works. Alright guys, we're going to plug in some power. Okay. And we're going to try out their test leads. And let's see what happens here. Okay, well I guess first I should just see if it even powers up before I bother doing that, right? I'm going to hold it by the leads. I think I just heard it. Oh, that was my other fan. So, okay, it's set for 1 volt and 6 amps. I'm going to turn on the output and see if it thinks it's going to do something. Okay, it's 1 volt and it's waiting for current. It says on CV. That's pretty cool. I'm going to zoom in a little bit so you can see this. Alright, looks like it's pulsating in the camera, but what I see here looks fine. Okay, I'm going to hold this and I'm going to short these guys. You know what, I'll turn it off first. Okay, now I'm going to turn on the load, see if it... Whoa, look at that. It's got 0.56 volt drop across these leads at 6 amps, 6.1 amps. But it's putting it out, and that's max current, 6 amps. So, geez guys, this thing looks like it works just fine. Okay, I'm going to adjust the voltage. Okay, let's see. Hit that. If I hit it twice, hit the current. Okay, so go back to voltage. Okay, that changes that digit. If I put, oh, okay, then it changes that digit. Let me push again. Yeah, that's pretty sweet. So there's 32 volts. Okay, I'm going to go ahead and turn it on. Max power, here it goes. Again, 0.55 volt drop across these leads and 6 amps. That's pretty funny. Okay, you know what I'll do? Let me turn this off. They felt like they started warming up, maybe warmed up a little bit, but they felt fine. So I'm not sure how long they could do 6 amps, but they probably could do it all day. Now these things are fit in there nice and snug. So that's nice. Here, let's go to current. Okay, move it over here. Drop it down. I'm going to go to 0.1 amp. I want to see if that works. Yeah, 0 volts with only 0.1 amps. But, okay, you know what? Just to make sure it's actually putting out that current, let's go back to current. I'm going to go over here and I'm going to max this thing out. You know what? I'm just curious. Yeah, that's max. It won't let me go any higher. So it's 32 volts, 6.1 amps. Okay? So hold on a sec. Alright, we're going to try this Hioki meter. It is set at DC current. When I turn it on, it just goes right to DC. I don't know if you remembered from last time. Let's try that out. There's AC. Turn it off. Turn it on. Nope. It goes right to DC. Okay, well, that's interesting. I'd almost think a meter like this would switch to AC. But I'm going to go ahead and stick on here. And we're going to watch this display here. I'll turn on the light for you. It's got a nice even backlight too. Okay, here, let's zoom out just a little bit. Okay, I'm going to reach over and push this and let's see what happens. Yeah, oh, well, I got it the wrong way. Minus 6 amps. So there you go. Pretty cool. Now this does have an inrush. I'm going to turn it off. And let's see if it actually, you know, goes right to 6 amps or if it does an inrush thing. Okay. Okay, there's peak. It's waiting for something to happen. Let's do it. Look at that, 6.1 amps. Or, oh, it might have peaked out at 15 amps, then went to 6.1. Wow. Okay. So this thing has some oomph to it. Yeah, you know, it looks like this thing's going to work fine. Alright guys, so I've got multimeter, my scope, the mix sig with the differential probe up here. Let me just show you that. This fancy little differential probe that came with it, pretty cool. And here, I'll show you the measurements down here. So I've got this 4 ohm, 200 watt load hooked up to it, okay? And got the differential probe, the multimeter probes, all that stuff, so that we can just kind of see, you know, what's going on. I just want to probe everything, make sure I'm taking a measurement here, but I want to make sure these guys measure right and see if it compares to this, okay? So let's go ahead and turn this on. I got maxed out. We're just going to go ahead and turn it on. Okay, now it loaded it down to 25.4 because 6 ohms, or I'm sorry, 6 amps into 4 ohms is going to be 24 volts, right? You know, times 0.1, right? It says 25.4, but over here it says 24.91. And over here it says 24.8. So either the meter's wrong, or you know how we saw that 0.5 volts before? I think that's because that's what we're seeing in the probe. So if we take off that oh hey, there's a fan kicking on. Can you hear that? I'm going to leave it on. I'm going to edit it out after this, but I left it on just long enough for you can hear that. Can you hear that? Okay, I'm going to shut up my mouth. So it's not terribly loud, but it's definitely on, okay? And it's probably because it's putting out 6 amps max power. So I'm gonna edit it out at this point. But anyway, if you take off that 0.5, well, or if you add 0.5 to these, it'd be 25.3, right? 25.3. So let's just see if we can prove that theory. Whoa, little sparkies I disconnect. Okay, so we're gonna come over here and I'm gonna pull these out. Just wait, hold it. Can I reach in? I don't think I can get it. Oh, here, maybe if I screw these out just a little bit, I could reach in there. I was just gonna pull out the banana plugs, which is kind of the same thing. 25.344. So that is pretty darn accurate. Okay. And we saw the current was pretty darn accurate too with the Hioki. So yeah, and now look how smooth that looks. That looks clean. I don't have any bandwidth limiting or anything like that, but I'm going to turn this on AC, okay, so we can zoom in on the AC. Oh, here, let me just zero that, and then I will zoom in 2.5, 1 volt, half a volt. Okay, so we have a little bit of noise on it. 100 millivolts. Okay, let's we're gonna zoom in on this noise. Okay, it's just little spiky stuff. Alright guys, I'm just gonna freeze the display. Wait, I gotta get a little bit more. Okay, freeze it. Okay, that's the switching. That's probably when transistors turn on, turn off, turn on, turn off. So we're seeing some switching, and let's see what the frequency of that switcher is. We'll go to the bigger spike here, and where's my other cursor? And my big spike there, and that's about 65 kilohertz. That sounds about right. I'm going to doubt that they have a 65 kilohertz switcher in there. So that's just, you know, that kind of noise can be cleaned up really easily. See, we're not seeing moving the display. We're not seeing low frequency ripple a little bit. See, from that step to this step, a little bit of low frequency ripple, but it's mostly these noise spikes. Alright guys, I just happen to have this little 63 nanofarad poly. What I want to show you is that kind of noise. It's low energy, just that spiky thing. Let me see if I can somehow reach across here to see what this will do. Okay, there we go. I just got more cycles so it was more obvious, but you can see just a really small 68 nanofarad cap. Whoa, get a little sparky there. Anyway, yeah, so that it doesn't take very much capacitance. So basically, when you hook this power supply up to any circuit that has capacitors at the input, it's going to clean up the switching stuff. Or, you know, we could probably even look at maybe adding some capacitors right here at the output leads, like just a small cap, and clean up some, you know, of the switching cycle. Alright guys, I zoomed in on it because I just realized maybe you couldn't see that. I'm going to try to get that cap across there again. It's kind of hard because it's small caps with short leads, but let's see if I can do it. Yeah, there we go. Okay, now see that it's kind of hard. Maybe here, maybe get more cycles in there. And then you can see how that, just that real small cap, 68 nanofarads, does a pretty good job at cleaning up a lot of that. It's just high energy. As a matter of fact, the differential probes I'm using, they're not the ideal for taking current, the ripple measurements. They'll pick up noise. So, yeah. Anyway, this is I'm pretty impressed with this power supply. For 6 amps output, ooh, that resistor's getting nice and toasty. Wow, that is pretty warm right now. That's why the fan's running, because the power supply's here. Let's just turn this on. And I let go. Yeah, 168C. I'm going to turn that off. That's why the fan's running in here. Wonder how long it'll take to turn off, but that resistor must be pretty hot. Get these leads away from that. Wow. So yeah, pretty hot. Yeah, that was 144 watts. 6 amps, well, it's a little bit higher than that. 6 amps at a 4 ohms, 6 times I squared R, right? 6 times 6, 36 times 4. So 144 watts with, yeah. And I didn't take into account the 0.1. Yeah, with the 0.1 in there, it comes out to 148.8. And also, remember the wire. Now, you know, these wires, they didn't really get that hot. They're warm, but they didn't, you know, they didn't get that hot. So, I think they'll handle the 6 amps this guy puts out. But yeah, it only took about, you know, a minute, maybe 2. It didn't take very long before the fans shut down. So, yeah, it cooled itself off pretty fast. Okay, now it's already warmed up, so, and this resistor is super hot. But I'm going to turn it to, let's see, what should we do? Thinking go to, say, 2 amps. Drop it down. Okay, 1.3 amps, since I'm already there. Let's just turn that on. Just wondering, let's see. It says it's on, but no current flow. What happened? Oh, my lead came off. Hold on a sec. When I moved them away, I kind of pulled it off, I guess. Okay, there we go. No fan. Doesn't turn on right away. I'll let you know. I'm going to count down, and I'll come back and tell you if the fans turn on. Alright guys, what do you think? Now, I've had the resistor still really hot because I'm putting in that 1.3 amp still. Fan hasn't kicked on. So I think that was only because of the high power. But yeah, it's nice that the fan doesn't turn on when it doesn't need to be on. Nice and quiet. But you know what, guys? This thing is so small to put out 32 volts at 6 amps. I'm impressed. Plus the memory functions. I hit a couple of them and people had things set up here. I wonder if I hit it when it's running. Oh, it stays on and it goes right to the, so you know what? That's pretty cool. You could do a step load test because it went to 0.4 at 0.1 amps. So now it's a 4 ohm resistor, so whatever the current's set at, the voltage is going to go there as long as, you know, it can, right? So it, memory 2 is 1 amp. Memory 3 is 2 amps. This must be from factory. I don't think somebody did this. Maybe somebody did, but okay. Memory, okay, 3.5 amps was memory 4, and the fan kicked on. And memory 5 is 5 amps. So I'll go back to 2. So that's pretty cool. You can do little step load changes. So when you're testing, say, a power supply or something, you can go from whatever you want, you know, within this range, 1 amp to say 5 amps, and you can do a step load, or I mean a step line input. So you can step the input voltage to your thing to see how it behaves. So yeah, the fan just turned off. So it turned on for a moment, turned back off after, and it's set at 1 amp. So yeah, man, I am super impressed. This is, God, this has to be the best deal. I've got a lot of power supplies, you can see. I really like these Kaiweets. They're really nice. They'll go to 10 amps, so they go twice the current, but man, they're twice as big and they don't have the memory functions and all the other things like the OCP and OVP. I mean, let me see. You can set them manually, the current, you know, anyway, they don't have preset functions like this thing. And also they don't have the on-off button. They have an on-off power, but not on-off to turn on the output. So I want to say this Matrix power supply, this Matrix company, I've been really impressed with their equipment. You know, the power supply up here, this LCR meter is awesome. So yeah, I'm really impressed with their stuff. I think they're going to send me something else a customer returned. I'm not sure if it's an active load or not, but yeah, this guy is really cool. Let me know what you guys think. Leave your comments down below if you have a Matrix. I mean, the encoder wheel's nice on the front. The size is amazing. You know what? If you guys want me to open this up, which I guess I should have done, but trying to make the video short and I actually just kind of forgot. I'm kind of excited about this power supply. But yeah, if you guys want me to open it up, take a look at it, maybe we can put a little small cap inside to get rid of some of that high frequency noise. That high frequency noise, I'm not too worried about it because if, you know, I'm powering up a resistor here, but if you're powering up any kind of electronic thing that's going to have input capacitors, that should filter out that noise because it is low energy. It's just spiky stuff. So, but yeah, maybe we can open it up and see if we can clean it up at the output, huh? God, I'm really amazed with this power supply. Thanks Matrix for sending it out to me for free. That's awesome. And I don't mind that it has a little scratchies on the front. Heck, I got a lot of stuff with scratchies on the front. As a matter of fact, this Mix 6 scope, it's all shiny again because the screen protector, which I thought I threw it down here on the floor, I was testing an amplifier and I accidentally knocked it over and it fell right against the scope and it just gouged the crap out of the front end. I was like, oh man, I couldn't believe it. Turned out it was just a screen protector. I don't know, that feels like plastic, but somehow it didn't scratch that at all and it really gouged the screen protector. So glad for that. I'm gonna have to see if I can get another screen protector. Although I like the glossy look, doesn't show well in the camera though. But all right guys, hey, this got long enough. 2 thumbs up to my patrons as always. Appreciate you guys. Happy holidays. I'm going to try to get some reviews out on some other things that I've got here. And I'm going to just try to pump out some videos this week to get the reviews out so people can have a chance to maybe go buy this stuff. But yeah, I like this guy a lot. And I think the price, oh shoot, I'll put the price here, but I think it's right around $50 for this, US, from Amazon. So I'll put the link. Appreciate you using the links. Doesn't cost you anything extra. Free way to support the channel. And you become a patron if you like. Links down below. in the video description down below. And also there's YouTube added a one-time thank you button. So that's really awesome they did that. You buy me a cup of coffee. Alright guys, hey, thanks for watching. I appreciate it. And thank you, Matrix. We'll see you next time.